You are standing in the middle of the Milky Way, looking toward its heart, and something is screaming at you. Not one thing, 10 things, 10 different signals, in 10 different languages, all coming from the same place, the center of our galaxy. We've been picking them up for decades, and we still have no idea what most of them mean. Here's what we do know. The galactic center sits 26,000 light-years away. If you drove there at 60 miles per hour, it would take 280 trillion years. That's 20,000 times the current age of the universe. You would not make it. But distance isn't even the main problem. The real problem is what's between us and it. The galactic center is completely invisible. Not dim, not faint, but totally hidden behind a wall of interstellar dust so thick that no visible light gets through. Everything we know about that place comes from wavelengths our eyes can't see. Radio waves, infrared, X-rays, gamma rays. We're essentially reading a book through the cover. And what's inside is extreme in a way that's hard to overstate. 10 million stars packed into a space roughly 3 light-years across. The density is 10,000 times higher than the neighborhood our sun lives in. At the center of all of it sits Sagittarius A star, a black hole weighing 4.3 million times what our sun weighs. It should be the loudest, most violent thing in the galaxy. Instead, it's shining at about 1/billionth of its theoretical maximum brightness. That's the first weird thing. A monster that's almost completely silent. And then, coming from all around it, 10 signals that nobody can explain. Number 1, the positron factory. Since 1972, over 50 years ago, a telescope has been picking up a very specific frequency of gamma radiation from the galactic center. Not a broad hiss of energy. A sharp, precise line at exactly 511 kilo-electron volts. That number isn't random, it's a signature. It's the exact energy released when a particle of matter and a particle of antimatter destroy each other. Something at the center of our galaxy is annihilating matter and antimatter at a rate of more than 10 trillion pairs every single second, continuously, without stopping. For at least 50 years of observation, probably longer, that's 10 followed by 12 zeros per second, every second. We have mapped exactly where it's coming from. There's a huge spherical cloud of this signal, a glowing halo of antimatter annihilation centered on the black hole, stretching 10 degrees in every direction. Then a disk component running along the galactic plane. ESA's integral telescope has been staring at this for over 20 years, and the signal is still there, still sharp, still completely mysterious. Where are the positrons coming from? We don't know. Exploding stars produce some, but the wrong shape. Primordial black holes were proposed, then ruled out at over 99% confidence. Light dark matter was a serious candidate for years until satellite data tightened the constraints so hard most of those models stopped working. In November 2025, a team proposed something called excited dark matter, a version of dark matter that has 2 quantum energy states, like an atom that can absorb and release energy. When it de-excites, it can produce positrons. And here's the part that makes this interesting. That single model might connect this signal to 2 other signals on this list simultaneously. It's the first framework that even attempts to do that. It might be nothing. It's very new. And science takes time. But for 50 years, nothing is stuck. And whatever is producing 10 trillion annihilations per second has been doing it the whole time we've been looking. Number 2, the radio ghost. In 2020, astronomers sweeping the galactic center with a radio telescope picked up something that had no right to exist. It appeared 6 times between January and September, then went completely dark for 3 months, then came back. When it was on, it was bright. And then it would collapse in a single day. When it appeared, it was doing something almost nothing in the sky does. It was circularly polarized. That means the radio waves were spiraling, screwing through space like a corkscrew. Out of thousands of radio sources in the sky, fewer than 10 are circularly polarized. All of them are things we recognize. Pulsars, magnetized red dwarf stars, things with explanations. This was not one of those things. Scientists went through the entire catalog of known objects, flaring stars, ruled out because stars glow in infrared, and this had no infrared counterpart whatsoever. Pulsars, ruled out, because pulsars have a rhythm ticking like a metronome on millisecond timescales, and this had no regular rhythm. Magnetars, X-ray binaries, gamma-ray bursts, supernovae, ruled out, ruled out, ruled out, ruled out. There was no X-ray signal, no optical signal, no infrared. It existed only in radio, showed up when it wanted, and then disappeared. The closest match was a weird family of sources called Galactic Center radio transients, but even those don't have an explanation. And this didn't fully fit them either. The official scientific conclusion, we don't know what it is. It might be an entirely new class of object. The catalog of things the universe can be just got one entry longer. Number 3. The gamma-ray glow that won't resolve. In 2009, NASA's Fermi Space Telescope turned toward the Galactic Center and found too many gamma rays. Not slightly too many. Significantly, persistently, infuriatingly too many. In the 1 to 10 giga-electron-volt energy range, spreading out from the center in a smooth, spherical glow that nobody had predicted and nobody could explain. The glow is called the Galactic Center Excess. It is the most argued over signal in astrophysics, and it has two explanations, both compelling, both with problems. Explanation 1, dark matter. The shape of the glow almost perfectly matches what you'd expect if dark matter particles, specifically ones weighing about 40 to 50 times a proton, were colliding with each other, annihilating, and releasing gamma rays. And the rate at which they'd need to be doing this is exactly the rate that cosmology already predicts for dark matter that formed in the early universe. That's not a coincidence you get to just ignore. But the dwarf galaxies around the Milky Way are full of dark matter and almost nothing else, and they don't show the same glow. They should, if dark matter were the answer. Explanation 2. Millisecond pulsars. Ancient dead stars spinning hundreds of times per second scattered through the galactic center, each one emitting gamma rays, and together too small to see individually, but collectively bright enough to produce the excess. It's a city of dead stars so dense we can't resolve them. But pulsars get a kick when they're born, a violent shove from the explosion that created them, and over billions of years that kick should scatter them away from the center. Getting enough of them to stay put is genuinely difficult. In October 2025, new simulations using the Milky Way's actual merger history, all the ancient galaxy collisions that shaped us, showed that the dark matter in our galactic center might be lumpy and non-spherical in exactly the right way to explain the glow. Dark matter came roaring back as the leading candidate. Then, in 2026, a Chinese space telescope called DAMP independently confirmed the excess at 7 sigma significance. First detection that wasn't Fermi, consistent with the dark matter annihilation, same mass range, same rate. We still don't know. But 5 of the 10 signals on this list might all point back to the same answer. We'll come back to that. Number 4, the magnetic threads. These ones you can almost picture. Stretched across the galactic center, there are nearly 1,000 thin, elongated structures, filaments of radio emission that look, in false color images, like glowing threads. Some of them run parallel to each other, equally spaced like strings on a harp 150 light years long. Some cross at angles. Some are stacked so perfectly they look designed. Each thread is up to 150 light years long and only about 1.5 light years wide. The aspect ratio, the ratio of length to width, is like taking a single strand of human hair and stretching it to the length of a football field, except the football field is made of relativistic electrons moving at nearly the speed of light through magnetic fields measured at up to 1 milligauss, which sounds small and is actually enormous by interstellar standards. We have known about some of these since the 1980s. In 2022, Meerkat, a radio telescope array in South Africa, revealed that there were 10 times more of them than we thought. Nearly 1,000. And the electrons inside them have a problem. They're moving at close to the speed of light. That takes energy. Enormous energy. And there is no obvious source of that energy nearby. Normally, relativistic electrons come from somewhere dramatic. A pulsar, a black hole, a shock wave. Here, they just seem to exist. Sitting there, spinning through magnetic fields, glowing. At one point in the 1990s, someone proposed that these filaments might be cosmic strings, hypothetical cracks in the fabric of space-time left over from the Big Bang. They were ruled out when it became clear that cosmic strings shouldn't split, and these things do split. They also shouldn't oscillate in certain ways, and these do that too. They've now been found in other galaxies as well, always near the core, always near an active nucleus, which is either a clue or just makes the mystery bigger, depending on how you feel about mysteries. Nobody knows what powers them. Number 5. The bubbles. In 2010, NASA's Fermi telescope was doing a broad survey of the gamma-ray sky when someone noticed something strange. There were two enormous structures rising above and below the galactic center, bubbles of gamma-ray emission, perfectly symmetrical, stretching 25,000 light-years above the galactic plane and 25,000 light-years below it. 50,000 light-years tip to tip, nearly half the diameter of the entire Milky Way galaxy. If you could see these with your naked eye, each bubble would span 110 degrees of sky, bigger than your full field of vision, rising from where the galactic center is, a dim smear in Sagittarius, all the way past the top of the sky and down the other side. In 2020, an X-ray telescope called Rosetta found that there was something even larger wrapped around the Fermi bubbles, a second pair of bubbles visible in X-rays extending even further. The full structure dwarfs anything else in our galaxy. What caused them? Two theories. The first, Sagittarius A star, our black hole, fired off a colossal jet of energy roughly 2.6 million years ago. Not a flare. A sustained eruption lasting about 100,000 years, so powerful it inflated these two bubbles like a nuclear balloon. The simulations match. The energy budget works. The second theory, a starburst, a period of furious star formation in the galactic center, a wind of stellar explosions blowing outward over millions of years, building up pressure until the galaxy itself exhaled. In 2023, researchers found that the northern bubble is slightly larger than the southern one. That asymmetry suggests something is pushing against it. A wind flowing through the space between galaxies, bending our exhale slightly off-center. Here's the thing about 2.6 million years ago. That's when Homo habilis appeared on Earth. Our ancestors were picking up rocks for the first time while the center of our galaxy was erupting with something close to an active galactic nucleus. That's not a cause and effect. It's just a coincidence. But it's a coincidence worth sitting with. Number 6, the particle accelerator. Everything so far has been radiation, signals in different frequencies, patterns in the glow. This one is different. This one is physical. The galactic center is accelerating protons, the heavy cores of hydrogen atoms, to energies that dwarf anything we can produce. 1 PD electron volt, 10 to the power of 15 electron volts. That makes the galactic center a pevatron, a particle accelerator roughly 100 times more powerful than the Large Hadron Collider, the biggest and most expensive machine humanity has ever built. When those accelerated protons collide with the gas clouds near the galactic center, they produce gamma rays, secondary radiation like sparks from an impact. And in 2024, the HWC Observatory detected those gamma rays at energies above 100 tera electron volts with no spectral cutoff. The signal just keeps going. From 6 tera electron volts all the way out to 114 tera electron volts, one clean, unbroken line of power with no ceiling in sight. Normally, particle accelerators in space have a maximum, supernovae cut off, pulsars cut off. Whatever this is, it hasn't cut off yet. It is running at or beyond the limits of what our current physics says should be possible. Where exactly is it? Probably Sagittarius A star or the dense star clusters immediately around it. Exactly how it works and how something without a collider ring or superconducting magnets is doing what CERN can't is completely unknown. And when those protons collide, they don't just produce gamma rays. Number 7, the ghost particles. They produce neutrinos too. Neutrinos are the closest thing the universe has to nothing. They have almost no mass. They carry no electric charge. They interact with almost nothing. Right now, 1 trillion of them are passing through your thumbnail every second. They came from the sun. They went straight through the earth to get to you. You didn't feel it. You will never feel it. That's also what makes them useful. A neutrino that points toward the galactic center actually came from the galactic center. It didn't get bent by magnetic fields, it didn't scatter off gas clouds, it just went straight. In July 2023, IceCube, a cubic kilometer of Antarctic ice packed with light sensors buried 1.5 kilometers underground at the South Pole, announced the first detection of high-energy neutrinos coming from the galactic plane. 10 years of data, machine learning, 4.5 Cygmi significance. The galactic center and everything near it is producing neutrinos in the tera electron volt range, which makes sense because that's exactly what the pevatron should be doing. When protons collide hard enough, you get gamma rays and neutrinos in comparable amounts. We've now detected both, but we can't yet tell if they're coming from one source or 100, whether it's the black hole itself or a diffuse cloud of collisions spread across the whole center. IceCube Gen 2, a planned expansion 8 times the current size, might resolve that. For now, something in the core is so energetic that even the universe's most antisocial particles can't ignore it. Number 8. The black hole that won't stop. You were probably expecting Sagittarius A star to show up earlier. It's been here the whole time. The black hole at the center of our galaxy is, by any reasonable standard, supposed to be quiet. It's what's called low luminosity. At its current output, it's shining at 1/billionth of the brightness it could theoretically achieve. For a 4 million solar mass black hole, that is almost impossibly dim. Astronomers have spent decades treating it as essentially dormant. It is not dormant. On January 5, 2015, Chandra's X-ray telescope caught a flare 400 times brighter than the baseline. Record breaker, cause unknown, possibly a disrupted asteroid, possibly tangled magnetic field lines snapping. On May 13, 2019, astronomers at the Keck Observatory watched the black hole become 75 times brighter in infrared than anything ever previously recorded. Twice the level of any historical measurement. Telescope teams around the world redirected toward it within hours. We still don't know what caused it. In April 2024, the James Webb Space Telescope watched Sagittarius A star for 48 hours across 1 year. The results dismantled the dormant model. 5 to 6 major flares per day, constant low-level flickering. The black hole was never actually quiet. We just weren't looking carefully enough. And then there's what happened 200 years ago. In 2023, a telescope called IRIP detected polarized X-rays coming from molecular gas clouds near Sagittarius A star. The polarization angle pointed like a compass directly at the black hole. Those clouds were reflecting. They were lit up from the inside by a flare so powerful it was still bouncing around the galactic center 2 centuries later. The math said, roughly 200 years ago, Sagittarius A star briefly produced X-rays at the level of a low luminosity active galactic nucleus, 1 million times its current output. Then it stopped. The light from that flare has been reaching us secondhand ever since. The Fermi bubbles suggest something far more violent happened 2.6 million years ago. And the positron factory, Signal 1, has been running for as long as we've been watching. The black hole is not the background. It might be the explanation for everything. Number 9. The things that shouldn't survive. Close to the black hole, very close, within a fraction of a light year, there are things orbiting that the black hole should have destroyed. They're called G objects. There are about 10 of them, confirmed. When you look at them in infrared, they look like gas clouds, diffuse, warm, emitting the signatures of ionized hydrogen and heated dust. But when you track their motion, they behave exactly like stars. Compact, coherent, following precise orbital paths at enormous velocities. When G2 was discovered in 2012, astronomers were excited in the way scientists get excited when something is about to be destroyed. Its orbit said it would swing past Sagittarius A star in 2013 and 2014, close enough that the black hole's gravity should have shredded it. Telescopes around the world watched, predictions were published, and then G2 came around the corner of the closest approach and kept going. Intact, basically unchanged. That's only possible if there's a star inside it. Something with enough gravitational self-binding to resist the tidal forces, a star wearing a cloud of gas like an overcoat. Then there's X7, discovered a couple of years ago, moving at about 700 miles per second, already visibly stretching, and you can watch the tidal forces pulling it apart in real-time imaging. Its closest approach will happen around 2036, and unlike G2, it probably won't survive. We're going to watch a strange hybrid object get torn to pieces by a black hole, in real time, in our lifetimes. Around these same G objects orbits something even harder to explain. Over 30 young massive stars, the kind that should take giant cold gas clouds to form. In a region where the black hole's gravity makes that completely impossible. They're called the S stars. They shouldn't be there. The tidal forces should have ripped apart any gas cloud before it could collapse into a star. They exist anyway. And then, the old stars that should be there and aren't. Theory predicts a dense cluster of ancient red giants packed right up against the black hole. In 2009, someone looked and found a hole instead. A deficit. The opposite of what the model predicted. The galactic center breaks stellar physics in both directions at once. Number 10. The cosmic burper and the missing pulsars. In 2002, a radio telescope called the VLA found something emitting 10-minute bursts of radio energy every 77 minutes, repeating like clockwork, located right near the galactic center. No X-ray signal, no optical signal, no explanation. It got nicknamed the cosmic burper. There are 2 other confirmed members of this family and called Galactic Center radio transients, and a few more candidates. None of them fit any known category of radio emitter. White dwarf pulsars have been proposed. Brown dwarfs emitting coherent radio bursts. An entirely new class of object. Nothing has been confirmed for over 20 years, but those might actually be connected to a deeper mystery. There should be roughly 10,000 pulsars within a single parsec of Sagittarius A star, churned out by the extreme star formation and death rate in that environment, scattered through the core. We have found almost none of them. The reason is that the dense turbulent plasma near the black hole scatters their radio pulses, smearing them out until they're undetectable. They're there. We just can't hear them. In February 2026, the Breakthrough Listen Galactic Center survey, the deepest pulsar search ever attempted in that direction, found something. A millisecond pulsar candidate, not confirmed yet. But if it is a pulsar, if it's sitting that close to a 4 million solar mass black hole, it becomes the most extreme test of Einstein's general relativity ever attempted. A spinning neutron star in the most warped space-time in the galaxy, ticking like a precision clock, telling us exactly how bent the universe gets in that neighborhood. We've been looking for one of those for decades. So here's where we are. 10 signals. 10 different types of impossible. Gamma rays announcing antimatter at industrial scale. A radio source the entire catalog can't identify. A gamma ray glow that's either dark matter or 10,000 hidden dead stars. 1,000 magnetic threads with nothing powering them. 2 galaxy-sized bubbles with no confirmed origin. A particle accelerator 100 times beyond the LHC. Ghost particles from the deepest place in the Milky Way. A black hole that flares 5 times a day and echoes centuries into the future. Objects that survive what shouldn't be survivable. And radio bursts from something that might not be any kind of thing we've named. 5 of them might connect to dark matter. A single model proposed in 2025 links 3 of them simultaneously, and that's either the first thread of an answer or the most expensive coincidence in physics. Every telescope we've pointed at the galactic center, Fermi, JWST, Meerkat, Rosetta, IceCube, found something it didn't expect. Every single one. We are not running out of signals. We are running out of explanations. The center of our galaxy has been talking for over 50 years. We've built bigger ears, we still don't speak the language.